Hello and welcome back. If you're here for the first time, I'm really glad you found this. This channel is a quiet place. No rush, no noise, just long, slow conversations about the universe and the world, and all the strange, fascinating things tucked inside it. Tonight's topic is one I've been wanting to sit with for a while. We're going to talk about the end of everything. Not dramatically, nothing here is dramatic, but honestly, and gently, and with a lot of wonder. Because the way the universe eventually winds down is not frightening when you really look at it. It's actually one of the most peaceful things I've ever thought about. So, get comfortable. Let the day go. This one takes its time. Step outside on a clear night, far from the city, and look up. You will see thousands of stars, maybe tens of thousands. If the sky is dark enough and the air is still, and somewhere beyond what your eye can follow, there are hundreds of billions more, whole galaxies, each one containing hundreds of billions of stars of their own. The universe, as you stand there looking up at it, is extraordinarily full. It is warm in places and bright and restless with energy that has been moving for longer than anything we know of. It is easy, looking up at a sky like that, to feel like the universe has always been this way, like it will always be this way. But the truth is quieter than that. The universe has a story, and like most stories, it has a beginning, a long and eventful middle, and very slowly, very gently, an ending. We are living in the middle right now, the bright, loud, active middle. Stars are being born, galaxies are spinning. Light is traveling across distances so vast that the numbers lose all meaning before they reach us. But the middle will not last forever. What I want to tell you about tonight is what comes after. Not as something frightening or bleak, but as something strangely beautiful. A slow, peaceful unwinding. A gradual quieting of everything that exists. The slow death of the universe. To understand where the universe is going, it helps to understand where it is now. We are currently living in what astronomers sometimes call the Stelliferous Era, which is simply a Latin-flavored way of saying the age of stars. It began a few 100 million years after the Big Bang, when the first stars ignited in the darkness. And it will continue for an almost incomprehensible stretch of time into the future, something in the range of 100 trillion years from now. 100 trillion years. It is worth sitting with a number like that for a moment, not to calculate it, but just to feel the weight of it. Every civilization that has ever existed on Earth, every mountain range that has ever risen and eroded back to dust, every ocean that has formed and dried and reformed. All of that happened within the last 4.5 billion years, and 100 trillion is roughly 20,000 times larger than that. The Stelliferous Era is, in human terms, essentially eternal. It stretches forward in time so far that it barely seems fair to call it an era at all, and yet it ends. Right now, scattered across the universe in every direction. Clouds of gas and dust are slowly collapsing under their own gravity. The gas gathers, grows dense, grows hot, until the pressure at the center becomes great enough to ignite nuclear fusion, and a new star is born. It blazes into existence, radiating light and heat and energy in all directions. Stars like our own sun will burn steadily for billions of years before they exhaust their fuel. This is the universe as we know it, active, bright, full of burning things. But here is something worth knowing. The rate at which new stars are being born has already been slowing down for a very long time. The universe made most of its stars a long time ago. Around 10 billion years ago, give or take, there was a kind of golden age of star formation. Galaxies were producing new stars at an extraordinary rate, one after another, bright and hot and enormous, burning fast through their fuel. The universe was denser then, the gas clouds were richer, everything was closer together. Since then, the pace has been dropping, slowly, almost imperceptibly. The great star-forming regions of the universe have been thinning. The raw material, the hydrogen and helium, the loose clouds of gas drifting between galaxies, has gradually been used up. Some of it was pulled into stars. Some of it was scattered by the explosions of dying stars. Some of it simply spread further and further apart as the universe continued to expand. Today, the universe is still forming new stars, but it is forming them at only a fraction of the rate it once did, and that fraction will keep shrinking. Eventually, over timescales so long that no human language was ever built to describe them, the great nurseries of stars will run dry. The gas clouds will thin to nothing. The galaxies will grow quiet, one by one, as their last new stars ignite and there is nothing left to replace them. Imagine a city at dusk, lights flickering on in windows, one here and one there. Fewer and fewer until the last one dims. The city does not end dramatically. It simply grows quieter. The universe will go out something like that. Long after the last star has finished forming, the stars that remain will keep burning for a while. The smallest ones, the dim red dwarf stars, are extraordinarily frugal with their fuel. They burn so slowly and so efficiently that they can last for trillions of years, far, far longer than our own sun. In the very far future, in galaxies that have long since stopped making new stars, these small red lights will be the last ones burning. Quiet and faint and ancient, drifting through emptied space, but even they, eventually, will go dark. When a star exhausts the last of its fuel, what remains depends on how large it was. The smaller stars, stars like the sun and smaller, will slowly shed their outer layers into space and leave behind a dense glowing remnant called a white dwarf. A white dwarf is roughly the size of the Earth, but far more dense. It contains all that is left of a star, compressed into a small, slowly cooling ember. In the current universe, white dwarfs still glow. They radiate the heat that remains from their formation, but they are not burning anything new. They are simply cooling very, very slowly over an almost unimaginable stretch of time. Even that residual warmth will fade. Astronomers call what comes next the black dwarf a cold, dark, inert remnant of a star, not burning, not glowing, simply drifting through the universe like a stone, carrying the memory of a star in its mass, but giving off no light at all. By the time the universe has grown cold enough to produce true black dwarfs in significant numbers, the timescale involved is so vast that it makes the age of the Stelliferous Era look brief by comparison. We are talking about numbers with so many zeros that writing them out would serve no purpose. The universe in this era will be very dark, very still, very cold. Not violently empty, just quietly. So, there will still be things in it, but the light will be almost entirely gone. There's a strange and beautiful detail hiding in the far future that I want to share with you. Even in the deepest darkness, something will still be happening. The largest remnants of the universe, the black holes left behind by the most massive stars and at the centers of galaxies, will persist long after everything else has gone quiet. Black holes are the most enduring structures we know of. They consume rather than emit. They gather the last traces of matter that drift close to them. But even black holes, it turns out, are not permanent. In the 1970s, the physicist Stephen Hawking described a process, quiet and theoretical and almost impossibly slow, by which black holes very gradually lose mass over time. The mathematics involves the strange behavior of space itself near the edge of a black hole. In simple terms, the black hole slowly, almost imperceptibly, leaks. This process is called Hawking radiation, and the rate at which it happens is extraordinarily slow. A black hole the mass of the Sun would take far longer than the current age of the universe to lose even a small fraction of itself this way. But time in the far future is not in short supply. Over durations that require entirely new language to describe, durations so long that the entire current age of the universe would fit into them like a single grain of sand on an infinite beach. Even the largest black holes will fade. They will grow smaller and smaller, and finally, in a last brief flare of energy, they will vanish. And when the last black hole goes dark, there will be nothing left that we would recognize as structure. No stars, no planets, no light. Just an almost perfectly even, almost perfectly cold expanse of space, scattered with the faintest traces of particles, slowly spreading apart as the universe continues its quiet expansion. This is sometimes called the heat death of the universe. Though it has nothing to do with heat, really. It is the opposite. It is the point at which everything has reached the same temperature, a temperature barely above absolute zero, and nothing more can happen, because there is no longer any difference between one place and another. No flow of energy, no change, perfect stillness. It is strange when you let yourself think about all of this, not to feel something, not fear, exactly, more like a deep, quiet recognition. We are here right now, in the warmest and brightest chapter of a very long story. The universe around us is alive in a way it will never be again. Not in the same way. The stars that light up the night sky are burning through fuel that will not be replenished. The galaxies that scientists photograph are in a constant, slow process of winding down. Even the atoms in your body were forged in older stars that burned and died before the Earth existed. You are made of something that has already been a star. There is a kind of comfort in that. If you let it settle, the end of the universe is not something that will happen suddenly or violently. There is no explosion, no dramatic finale. It is simply a long, slow cooling. Like the way a stone wall holds the warmth of the afternoon sun long after the light has moved on, releasing that warmth slowly into the evening air until it is indistinguishable from everything around it. The universe will not end so much as it will grow still. And long before any of that stillness arrives, longer before it than our minds can truly hold, you and I will have returned to the same matter we were borrowed from. The atoms will drift on. They do not carry memory, but they carry existence. They will still be here. There is something in that worth sitting with. Somewhere out there tonight, a star is being born. A cloud of gas, patient for millions of years, has finally gathered enough of itself together. Heat is building at its center. Light is about to begin. And somewhere else, in a galaxy far older than our own, a small dim red star is burning through its last few billion years of fuel. It has been doing so for longer than the Earth has existed. It will continue long after the Earth is gone. The universe is full of both of these things at once, beginnings and endings, new light and fading light. And right now, in this moment, we sit in the middle of it all, watching the stars from the surface of a small, warm planet, breathing in the night air. The darkness is coming, but not tonight, not for longer than we could ever imagine. Tonight, the sky is still full of stars, and that is enough. Let the rest of it unfold slowly, as it always has. Let the universe do what it does. Right now, this moment is part of the bright middle. The long, warm chapter where things exist and move and matter. and you are here for it. Let your thoughts drift now, the way light drifts across the dark between galaxies, slowly, quietly, over distances too large for worry. There is nothing more to do tonight. Just rest. That's where I'll leave you tonight, with stars still burning and an unimaginable amount of time still ahead, for the universe and for you. If this kind of quiet made your evening a little slower, a little softer, I'm glad. That's all this is really for. Sleep well, and I'll see you in the next one.